Idle efficiency is the fourth type of energy saving technique or software energy saving technique. In the main objective of idle efficiency, or the way idle efficiency is achieved by minimizing the background activities. As shown in figure, we can notice that nearly 8 watt, if you see here, nearly 8 watt is consumed by the processor when it is idle state, it is in the idle state, and when that is what you say is more than C0 state. C0 state is a busy state, we know that. Only 5% of the time what the processor consumes is if it is maintained is, that is a 5 to 10%, then the efficiency can be achieved, the energy efficiency can be achieved. And it is very important to maintain the C0 at only 5 to 10% and 90% in idle state. Here the biggest challenge is to lower the idle floor by improving the application ideal efficiency, and with this it leads to efficient increase in the battery life. Now next is deep sea state redundancy. It is a subtopic of idle efficiency. So here deep sea state redundancy, in this one its main objective is to keep more into deep state sea state, that is more into the sleep state or idle state, and it is tried to maintain the deepest sea state, that is C6 to C7. Actually if the sea state comes like this, I'm not sure whether we have discussed like or this or not. Usually C0 is a busy state, and C1, C2, C3, C4 are the different level of sleep states or idle states, and C6 and C7 are a deepest sea state, and the application should be maintained in, or the device should be maintained in such a way that nearly in more than 90% of the time it should be in a deepest sea state, that is C6 or C7. So software should aim to keep the number of sea state transactions coming and going out of deep sea state as low as possible. So if that is maintained, that is if the more of the deep sea state is maintained, the efficiency, the energy efficiency can be achieved. Next is OS timer resolution. So if you consider the Windows operating system, it is using for every 15.6 millisecond it provides an hardware interrupt, it will give a interrupt. So exactly what this interrupt is doing is it is performing two actions. One is it updates the timer click count if full click has elapsed, and it checks whether the scheduled timer object is expired. So with this the energy efficiency can be achieved. Next is background activity. Most of us are familiar with this. Sometime what happens if your mobile gets slower, what we are doing is we just go to optimize option. So it is, what is optimization? We have to understand. When any process is running, along with that process some other sub processes also will be running in the background, which may be not necessary in some cases, but more the background activities are running, it will consume more power. So frequent periodic background activity increase can overall increase the power consumption of the system. Now what we can do is long running frequent events also, sometime it is also it also prevents the system from idling into the sea state. That means if some processes are running in the long duration, it will not allow the processor to go into the sleep state. Okay, now here background activities on the macro scale such as disk defragmentation, antivirus scan, and like also important for power saving. So disk defragmentation we have already discussed. Sometimes regular antivirus scanning is done, so that will keep our processor active. So we should make sure that as many as background activities are possible, just stop those processes. So the background activities are background processes which will be running or which will be in use without any need. Such background activities should be closed. The Windows 7 has introduced some unified background processes such as UBPM to minimize the power impact of background activities.